Now we're going to talk about intermolecular forces. Intermolecular forces are forces that are between molecules. So, what these do is they connect one molecule to another molecule. Technically, we're only supposed to use these terms for molecular covalence, but we expanded a little bit to talk about those that also work with network covalence and ionic compounds and metallic bonds. So, in our minds, we are viewing this as what takes the small pieces and joins them together into something we can actually see. And so when I say see, I mean literally see. So, for example, this is a crystal of copper sulfate, and it's far more than just one copper and one sulfate joined together. It's a whole bunch of them joined together into something that we can physically see. Um, so, usually we're going to be talking about a solid or a liquid, frequently a crystal form. The only time we can see gas is if it happens to be a colored gas, and that's usually an indication that it's also a poisonous gas. So most of the gases that we see, like nitrogen that's in our atmosphere, we don't so much notice. So I'm going to list the types that I'm going to go over, and I'm deliberately listing them in this order, though it's not necessarily the order I'm going to go over them. So we have our network covalence. And our network covalence, we have already said, have strong covalent bonds. Then we have our ionics. And we're going to be talking about electrostatic attractions. Then we're going to talk about hydrogen bonds, what's called dipole-dipole forces, dispersion forces, which are also called London dispersion forces, which is frequently abbreviated LDFs. You see that in some notations, or it's abbreviated dispersion force. And then we're going to talk about metallic bonds. I gave you an overview of these types in the last lesson. We're going to talk about them in a little bit more detail this time. These three are all the kinds that we'll see when we have a molecular covalent compound. Molecular covalent can be any of those three. These two together, you will sometimes hear called in a group of things called van der Waals forces. Depending on the teacher and the text, you might hear them more often than others. But if you hear van der Waals forces, it's these type of forces. But in network or molecular covalence, we can see all three of these types.